Production of ethanol. Production of ethanol. Fermentation. To make ethanol, you need glucose. The formula: glucose with yeast will produce 2 ethanol, 2 carbon dioxide. Condition required: you require to have a warm temperature around 25 to 35 degrees, and it need to be very little oxygen, absent of oxygen. Student, please remember the formula: 1 glucose produce 2 ethanol and 2 carbon dioxide. This is the important formula. Experiment aspect. In a jar of water, you put a spoon of sugar because you require glucose and yeast. So now this solution is a sugary solution with yeast. You put a cotton wool in the mouth of the jar so to create absence of oxygen. Now you put it in the incubator to create a warm 25 to 35 degree temperature. And then with the yeast and the glucose, you will start fermenting. You also require to record from day 1 to day 7. You have to wait every day. Why you waiting? Because you see the weight will change. Why weight changing? Because in fermentation, carbon dioxide that could produce will escape through the cotton wool, so it causing the weight loss. So the next step, the ethanol that you produce will be maximum of 12% only. Distillation. Ethanol concentration once reached 12%, yeast cannot survive and the fermentation will stop, because high concentration of ethanol is toxic to the yeast. But the ethanol solution can be further distilled to produce a higher ethanol concentration, can reach up to 90% higher. As you see in the market, they bear 5% ethanol. But when it comes to wine and brandy, wine can add 18%, or brandy can go up to 40% pure of ethanol. That is done through distillation. Distillation. You need 2 jars, and in the mid you put a condenser, and you need to have a temperature to monitor. First step, you put the sugary solution with partial of the ethanol, that 12%, onto the jar. You turn up the heat to raise the temperature. When the temperature rises up to 78 degrees, ethanol will evaporate, but the sugary solution will left behind, and it would not reach to the boiling point yet. So the ethanol vapor will pass down the condenser, and once it passes down the condenser, it will recondense back into liquid of ethanol. And this ethanol can reach up to 92% pure. And this is the step of distillation. The production of ethanol for the industrial alcohol, that is another way. This way is quite a shortcut. It's by hydration of ethene. Hydration of ethene. You need 300 degrees with the help of sulfuric acid as catalyst. How do you hydrating ethene? Hydrating means add water. So when you have ethene with water under dilute sulfuric acid with 300 degrees, it will become ethanol. Look onto the structure change. Ethene add water. Now the water will combine into this H and OH. This is ethanol. Hope students remember on the early chapter of ethene addition reaction that we've been mentioned before. So these things, it come back again. And actually this process is reversible. All you need to change is to change the concentration of sulfuric acid. If ethanol you put under a high concentrate sulfuric acid, it will turn back into ethene and water. So the ethanol, the water's been removed and back into ethene. So this step is called dehydration. Dehydrate, remove water. Student, please remember, dilute sulfuric acid can make ethanol. Dehydration, you need high concentrate sulfuric acid, and this process can reverse. Industrial alcohol can be up to 95% pure of ethanol, but it also will have 5% methanol, and methanol are extremely toxic. Please know, so industrial alcohol is not drinkable. It's toxic because it contains the methanol content. Drinking alcohol, that is always done through fermentation. Here's a summary of so far what we learned about ethene, ethanol, and many chemical reactions. We know ethanol can make into ethene. Ethene also can make into ethanol. They both have many chemical reactions. And we can look further. Where's ethene come from? Crude oil through cracking. Through cracking to make it into ethene. And ethene can produce ethanol. This is through the fossil fuel. But there's another way. If glucose through fermentation, distillation, you can get quite a pure ethanol. And ethanol also can produce into ethene. So the difference is glucose is more environmental friendly. Crude oil, that is using the fossil fuel. So these two are linked. Now we learned earlier cellulose. I hope students still remember what is cellulose. Cellulose is the long chain of glucose in the fiber form. They are a long chain of plant fiber called cellulose. Student, please remember. And what is the individual unit of cellulose? Glucose. Glucose. They bind together through condensation. I hope students still remember this type of polymerization. And then think about if I can break up this cellulose. If I can break up this cellulose back into individual glucose, now I can do it through fermentation. And this is talking about the biomass, cellulose. Can we go through this way? Yes, but this way have some difficulty. Because if we use enzyme or use concentrated sulfuric acid, they both can break cellulose into glucose, but they are not practical and they're very energy costly. So far we don't do this step. So far we cannot use cellulose into glucose. So student, I expect you to know what is cellulose. What is individual monomer of cellulose, glucose? What is biomass? What is the relation between ethanol and ethene? And these two process, student. So this page works as a beautiful summary for you, and you should know each step now.